Wonderful. Good evening, everyone. So I started exception handling in the previous class, and then we're going to finish that today. That's my goal, and if we have time, then I'll talk about JDK 1.5 new features. That's what I'm targeting for today. So as I told you, exceptions are the errors that are thrown by your code. So when you call a piece of code, that code can potentially throw the error. And those errors are called exceptions in Java area. And there are two kinds of exceptions typically. One are programmatic errors, like you have null pointer exceptions when you try to call a method on a null reference, and then array index out of bounds exception when you actually try to get an array element outside the boundaries. So those are called runtime exceptions or unchecked exceptions. But there are some exceptions that are thrown when something goes wrong. So for example, IO exception, as I told you, will happen when you're dealing with file IO. So you want to write to a file or you want to read from a file and file doesn't exist, then in that scenario, IO exception is thrown. Or you're trying to communicate with someone remotely, and unfortunately something happened with that service, it's not available anymore, then you'll get an exception called remote exception. So these are all called checked exceptions. So there are two kinds of exceptions. One is checked exception, the other one is unchecked exception or runtime exception. So checked exceptions are the expected exceptions. When you call a piece of code that's potentially risky, okay, then if you know that your piece of code is going to throw an exception, then declare that in your method signature. Okay, I'll get to that in a second. But before that, let me talk about the checked exceptions. So when you call a piece of code or a line of code, a method, a risky method, okay, that can potentially throw an exception. So for example, I'll throw an example there. So you are trying to transfer the balance. This is my favorite example. I'll keep using it until we talk about the transactions. I'm going to take this example. So you want to transfer some money from your checking account to savings account. So what happens if you don't have enough money in your checking account? You can't transfer it, right? When you don't have enough money. So this is what I want to do it. So I have $1,000 in my checking account and I have $2,000 in my savings account. I want to transfer $1,500. Okay, I don't have enough money here. Then in that case, you have to throw an error saying that, sorry, you don't have enough money. So your transfer method can potentially throw an error. What is that error or exception? From here onwards, I'll call an exception. So you can name this exception as insufficient balance exception, for example. We're going to look at it very soon. So your transfer method can potentially throw an insufficient balance exception if you don't have enough money in your checking account. So what is the method signature of your transfer? Your transfer method takes okay, how much you want to transfer from your checking account to savings account. That's what it does. Like, what's the amount? And then probably it can tell you whether it managed to do it or not. That's a return type, right? So in the event that you don't have enough money in your checking account, you can potentially throw an error. If you run into this kind of situation where a method can potentially throw an exception, so I'm the caller of this transfer method, I'm the client of this transfer method, okay? I'm calling this transfer method. I'm saying that, hey, can you transfer from checking account to $1,500 of from checking account to savings account. So when I call this transfer method, then what Java compiler says that is, hey, dude, you are calling a risky method here. This method could potentially throw you an error. Then when an exception is thrown, you have to do two things. You have to do two things, one of two things. One, if you know what to do, if you can recover from an exception, excuse me, I am not sure whether I started recording. Yes, I'm recording. Thanks. Sorry about it. So when you are making a call to a risky method that can potentially throw an exception, you have to do potentially two things, one of two things. One, if you know how to handle an exception, if you know how to recover from that exception, recovering in this case, meaning if you can grab the money from somewhere else and put it in a checking account, you think you can do it? Then catch the exception. If you don't know what to do, then you rethrow it to your client. You rethrow it to your client. So I'm making a call to this transfer method, asking this transfer method saying, hey, can you transfer $1,500 from checking account to savings account? Well, transfer will try to do that for you. But unfortunately, this transfer is a risky method, and this can potentially throw an error, throw an exception. Since it can potentially throw an exception, compiler will force me to do one of two things. One, you catch it and handle the exception gracefully. If you don't know what to do about that one, if you say, hey, I don't know what to do. If I don't have enough money, then what can I do? I don't have an option. Then in that case, rethrow it to your client. So someone may be calling you, right? So someone may be calling you. Let me take this chain here. So someone called you. This is you. And you call the transfer method of a different class. So I'm talking about objects. That's how objects communicate, right? So this is one class. This is one object. This object called this guy. And this object called the transfer method, and transfer method can potentially throw an exception. Then if that is a checked exception, meaning your code can potentially throw that exception, then compiler will force you to do one of two things. Either you catch it if you know what to do, or rethrow it. Meaning, what do you mean by rethrow it? Well, if you know how to handle it, I'll catch it and say, I'll do something about it. I'll recover it. If I don't know how to do it, at least I'll just log it, meaning I'll print all the details about the exception and then proceed. But if I don't want to do this one, if I don't know how to handle it, then rethrow it. You just throw it back to your calling client. And then what would you do? In your case, your method will be a risky method now. So when this guy calls, then compiler says that, dude, this method can potentially throw you an exception too. Then again, same rule is applicable. Either you catch it or rethrow it. Simple. When you get an error, you are left with two options to deal with that error. Either you catch it and handle it properly. If not, then rethrow it. So trickle up. So when A calls B, B calls C, and C calls D. If D throws an exception, if C caught it and did something about it, then everything is fine. Otherwise, C can rethrow it to B, B can rethrow it to A, and this can rethrow it all the way to your browser. That's why in some of the poorly designed web applications, if you look at it, you will see some big error messages. Ideally, they shouldn't show that to you. If they get null pointer exception, or if they get some error index out of bounds exception, I'm not sure how many times you have seen this one, but you will see this big stack trace there on the browser. Ideally, they shouldn't show that to you. I mean, that's the internal details. Why do you want to do is show it to customer and making them feel uncomfortable, right? At that time, handle it and say that, hey, an unknown exception, an unknown error has occurred. Please call 1-800 number and we'll take care of it, or something like that. So that's about the exceptions. We talked about it. So exception is also an object, by the way. So exception is a class. And this is inside a package called java.lang. This is a special package which you don't have to import it. So exception. Now, inside this exception, before I get into the details, actually I want to show you another example. I want to show you an example. I'll create a separate package. Oops. Oh, I already have. I created it already. Well, okay. One more, the second one. So in exception demo.java, in the previous class, I showed you this one, array index out of bounds exception. Well, you caught this one. See, the difference between checked exception is and unchecked exception is this one. String array names equal to Tom, Ramu, Nandakumar, and names of 3. You're asking for the 4th element that doesn't exist there. Okay? Then you got an exception saying that array index out of bounds exception. Hey, this is runtime exception, right? Meaning, how come my compiler did not help me here? Well, compiler doesn't know that. Because the nature of the array index out of bounds exception is a runtime exception, meaning it's something to do with your bad code. It's not going to help because there are only 3 elements in your string array, in your names array, but you're asking for the 4th element. Then obviously it throws the runtime exception. But what happens in the other case is, I'll show you now another example. Now, what I want to do here is, I want to write some piece of information into a file. Okay? So this is how I do it. So we have a file writer, file java.io.file writer. So new file writer. Here you specify what file you want to write to. c:"javatraining.txt. Okay? You have to escape that one. And then this is good. Now, what you have to do is there is another writer called print writer. Print writer out equal to new print writer. And now you can specify your file writer to that one. This is a couple of lines of code that you use to write something into a file on your disk. Okay. And now you say out dot write. This is Java training. Something like that. Okay. So this is how I do it. But there is a compilation issue. What is it saying here? See, there is a problem here. It's saying something. What is it saying? Let's take a look at it. It's saying unhandled exception type IO exception. What does it mean? What does it mean? Unhandled exception type IO exception. What it is telling you is this line of code, new file writer, is throwing an exception. This constructor, right? This is the constructor, right? So this constructor is throwing an exception called IO exception, and IO exception is in the category of checked exception. If a checked exception is thrown, your compiler will force you to do one of two things. Why does it force? Because this is a potential for an exception. When you do this one, new file writer, maybe this file doesn't exist. Maybe this directory doesn't exist. Maybe this whole C drive doesn't exist. Maybe if I say G drive or H drive, maybe H drive doesn't exist. So what happens in that case? So this is a risky code. You are calling a risky code. When you call risky code, then your compiler will force you to do one of two things. Dude, you're going to call a risky piece of code. Do something about it. What do you want to do? If an exception is thrown, in the event an IO exception is thrown, when is IO exception is thrown? If disk is not writable, or if the file doesn't exist, or the whole directory itself doesn't exist, or the whole drive itself doesn't exist, or if it is full. In that case, it will throw an IO exception. It's an error. But it's asking you to do one of two things. Do you know how to handle this scenario? Do you know how to handle this scenario? Well, if you know how to handle this scenario, then handle it. Otherwise, you rethrow it to your clients, whoever is calling this guy. Of course, this main method is not called by anyone, but in general, one object's method will be called by some other object, right? That's how the objects interact. When object A calls object B, if object B throws an error, then compiler will say that, hey, you either catch it or rethrow it to your client. What do you want to do? It's up to you. You can do two things here. Well, what you can do is you can put this in try. You can put this whole method, in fact, in a try block and say catch IO exception. And if IO exception, because you said you know how to handle in the case of IO exception. Okay, what do you want to do now? What do you want to do now? Well, what can you do if disk is not writable, right? You don't know, really speaking. So in that case, what would you do? You just print the whole error message, right? How do you print the whole error message? This exception has a method called print stack trace method. See that? Exception dot print stack trace. When you say that ex.print stack trace, then the whole stack trace will be printed, meaning the whole error message will be printed. But in the previous example, exception demo, it is still throwing an error, array index out of bounds exception. Our compiler did not force us to handle it. The reason is array index out of bounds exception is a runtime exception, and that is due to code. That happens due to bad code. There are only 3, and you're asking for 4th element. It's a bad code. It doesn't help. But here, you design your IO exception as a checked exception, meaning compiler, I'm forcing my client to do one of 2 things because he's dealing with risky piece of code. And he did it. He handled it. If you don't want to handle it, you know what you don't want to, do you know what to do when you don't want to handle it? We'll see next. But this is how you do it. Okay. Let's right click and then run as Java application. Well, nothing happened. Luckily, no errors. Let's go and see what happened in our C Java training.txt. Oh, there's nothing. Oops. Because I did not. Let me flush out. I have to close this connection, and in fact, I have to go flush it. Let's go and do it. Hey, see that? This is Java training by Venkat Hari. My students are great. So that's how it works. So you wrote something onto a file. Okay. And in fact, if you want to write into the next line, that's how you do it. It's a carriage written. So what did you observe just now? When you call a piece of code that throws a checked exception, we'll talk about, how many checked exceptions, how many runtime exceptions, the commonly used ones. We just started it. We will, throughout the session, we'll talk about so many exceptions. So IO exception falls in the category of checked exception. If there is a checked exception, then your compiler will ask you either to catch it or rethrow it. So how do you rethrow it? I don't know how to do it. Okay. Oh, by the way, I want to show you something. See what happens if you try to write to a H drive that doesn't exist. If you don't have it, then right click, run as Java application. Oh, see that? It threw an exception called file not found exception. H Java training.txt, the way the device is not ready. So you don't have a file as such. And it threw an exception because you printed the stack trace. Well, did you observe something here? The actual exception that is thrown is file not found exception. Okay, but you caught IO exception. Then how did it come here? These exceptions are also like regular objects, and you would see the polymorphic behavior. IO exception is a superclass of file not found exception. So all the either IO exception or all the subclasses of our IO exceptions will be caught by this line of code here. And then it will print the stack trace. So this is how it works. If you want me to draw the object structure here, there is a top level class called exception, java.lang.exception. And in fact, there is a top level class, even exceptions, that is throwable. Throwable is a top level class. Okay. And inside exception, you have one of the exceptions is called IO exceptions. Every time you deal with IO, file input output, okay? Every time you deal with writing to disk, writing to file and all that stuff, then IO exception can be potentially thrown. Then the subclass of IO exception is, one of these subclasses is file not found exception. If the file is not found, if you're trying to write to a file and if the file is not found, or if you're trying to read from a file and the file is not found, then file not found exception is thrown, and file not found exception is a subclass of IO exception. That is why when you caught IO exception, what happens is IO exception and all below, all the subclasses will be caught here. And then you are printing the error message. Hey, so what happens if I don't know what to do? Let's do about it. Let's talk that scenario. In this case, I handled it, right? This is what I call it, handling. So what I want to do here is, well, this guy is throwing an exception. What is it saying? Unhandled exception type IO exception. Dude, you did not do anything about it. Okay, you can do two things. See this one? Two quick fixes available. Yeah, your Eclipse is telling you to do one of these two things. Surround with try catch. When you do that, Eclipse can do that. Eclipse can do that. Of course, again here, I mean, what is the problem here? The local variable file writer may not have been initialized. Then you do it this way. Then you're good. So this line of code was throwing the exception and you caught it, right? You don't have to do that. So let's assume you don't know what to do. Okay. What I want to do here is I'll create a separate method, say public void print to a file. I'll say print to a file. And then I'll put this whole piece of code here. Okay. And then I'll call this print to a file here in my main method. How do I do that? Well, first, this is a static. This is not a static method. This is a non-static instance method. So I have to create an instance. Okay. Exception demo 2 ex equal to new exception demo 2 and ex dot print to a file. Well, I call this one. Now, what is it? What is happening? Who is the client of this method? This guy. Who is calling this print to a file method? This main method. So this is the client. This is what I was talking about. It doesn't have to be an object. It could be another method inside the same object. So now, let's take a look at it. So it is asking you to do one of two things, unhandled exception type IO exception, because IO exception is checked exception. Okay, now this time I don't want to handle it because if there is no file or something happened while writing a file, I don't want to deal with it. I don't know what to do. Let's rethrow it. Meaning, I will throw it back to my client. When you want to throw it back to your client, then you have to put that in your method signature. You have to explicitly say that my method can throw that IO exception because I'm not handling, right? Then if I don't handle it, as a client of me, it's your responsibility now to handle it, to do either one of two things, either catch it or rethrow it. Okay, I'm not doing it. How do I do that? Well, this is how you do it. Using, after the method, parenthesis, you say throws and whatever the exception that it's throwing. See that? Now my method is call. See this? My method is call. This method is not giving me any errors. But the problem is this main method. Now main method being the client of the print to a file method. Now this guy main method is calling this print to a file. And then this method can potentially throw an IO exception. And this IO exception happens to be a checked exception. And compiler is saying that, dude, this print to a file method can potentially throw an IO exception, unhandled exception. You did not do anything about it. What do you want to do? Do you know how to handle it? Then handle it by surrounding it with try catch. If you don't know what to do, then rethrow it. If you don't know what to do, then rethrow it. Even from main method, you rethrow it. Then you say throws IO exception. Like that. Then everyone is happy. Of course, who calls main method? JVM calls main method, then JVM will print the message. That's a different story. Right, like run as Java application. See that? You got the same information. but you did not put try catch this time because JVM has printed all the stack trace for you. But if someone else called this method, then he needs to do the same thing. If someone else calls this method, then he needs to do the same thing. Dude, this method can potentially throw an away exception, do one of two things, either catch it or rethrow it. Catch or rethrow, catch or rethrow, catch or rethrow. That's the mantra. This is how you rethrow it using a keyword called throws. And this is part of your method signature. By saying, what are you saying here? This whole method signature, I'm saying loosely, this whole method signature, you read that. My method name is print to a file, and this does not return anything because its return type is void, but this method can potentially throw an IO exception. Since that IO exception is a checked exception, then be ready to handle it. You have to do one of two things, either catch it or rethrow it. Beautiful. But if it's a runtime exception, then compiler does not force you to do it. Absolutely, you can do it if you need to. If you know for sure how to handle it, you can definitely catch it like the way we did it in exception demo here, like this. You can do it if you want to, but compiler doesn't force you because array index out of bounds exception is a unchecked exception or runtime exception. Well, I've been talking about checked exception, runtime exception, checked exception, runtime exception. What is the deal? Well, this is the deal. How do I know whether that's a checked exception or runtime exception? It's very simple. So exception has a subclass called runtime exception. Okay? This is how you define whether the method is a checked exception or not. If your exception is subclass of runtime exception, then that exception is called runtime exception or unchecked exception. In that case, compiler does not force you to do one of two things, either catch it or rethrow it. But if your exception is subclass of directly exception, the java.lang exception, if your exception is directly subclass of exception, not runtime exception, in that case, that is called checked exception. So this is called, all the exceptions that extends exception are called checked exceptions. And in the case of checked exceptions, compiler does not force you to, in the case of checked exception, compiler forces you to do one of two things, either catch it or rethrow it. And all the runtime exceptions, all the subclasses of runtime exceptions are called unchecked or runtime. That's all. So that's the story. So I told you that all of your exceptions are actually subclass of java.lang exceptions. Okay, now let's go to your IO exception. Let's go there. Where is your IO exception? Let's go there. Do you know how to go to the source file, IO exception? I know IO exception is a Java's code. Java is giving you that, right? It's part of the core Java piece. But you can go to the source file for this one. How? Just by clicking on F3 button. Just F3, then it takes you. See this public class IO exception extends exception. If your exception extends exception, not runtime exception, then this is called a checked exception. So this is a checked exception. So every time IO exception is thrown, everywhere IO exception is thrown, your compiler will force you, because this has to be handled. Somebody has to worry about it. Okay. Now let's take a look at the array index out of bounds exception. Let's go here and talk. Let's see array index out of bounds exception. Ooh. So array index out of bounds exception extends index out of bounds exception. Sure. Let's go to index out of bounds exception. Again, F3. See that? Index out of bounds exception is a runtime exception. So either you or your dad extends runtime exception. That's a runtime exception, and that's an unchecked exception. And in the case of unchecked exceptions, your compiler does not force you to handle it. It's up to you if you want to handle it, because those runtime exceptions are generally occur due to programmatic errors. Okay. So that's all. Any questions so far from anyone?
Yeah. Okay, Venkat, I have a question. Yeah. So we are caching the exceptions basically for our information, right?
One second, Nandakumar.
Okay.
Yeah, go ahead.
Okay, we are catching exceptions only to is for our information, right? Because depending on the exception, we show the message to the users. I mean, so we say, for example, we are getting file not found exception. Obviously, we are not going to show that error to the users, correct?
Sure.
Okay, 1 second, I can't hear properly. Okay, can you hear now?
Yes, yes.
Okay. So basically, it's for our information we are doing it, right? It's not for the user's purpose. So, so basically, say for example, here we have IO file not found exception or something else. So, depending on the exception, can we control to show a different message to the users, or it doesn't matter?
Absolutely, you can show different message to the user. Absolutely, you can, depending on the exception. But it's not only about showing it to the user, Nandakumar. It's mainly about handling. Handling is not only showing. Showing is part of the handle. I totally agree with you on that. But that's not the only. That's not the only handling scenario, right? I'll tell you something. So you're calling a remote web service, and if the remote web service is down, okay, you're making a call to PayPal,
okay,
to accept the payment. Okay, PayPal is down. So it obviously throws an exception saying that network exception or remote exception or something like that. Okay.
Yes.
And those kind of exceptions are going to be designed as checked exceptions, because that's a risky code, right?
Yes.
So your compiler will force you, even if your compiler doesn't force you. I mean, I'm saying those kind of exceptions have to be designed as checked exceptions, because you have to do something about it. You have to be forced to do something about it, and you do something about it. So you catch it. Maybe what do you want to do in that case? You don't want to show it to your user that your PayPal is down. I mean, probably user doesn't even know that you are dealing with PayPal.
Yes, I see what you're saying.
So what you want to do in that scenario is probably you want to retry it. So don't penalize the customer just because something happened within your system. So make some intelligent decisions based on the exception. So if PayPal is down, if you get remote exception, then retry it. Have a retry policy and say, I will retry this 10 times because I want to make customer happy. I don't want to tell them that, well, PayPal is down. Hey, what the heck is PayPal? I don't know. Okay. I mean, that's an internal vendor for you. Okay.
Yes.
To deal with your payment stuff. He doesn't know that you are dealing with a PayPal. Don't penalize me for that. Rather, you retry it and make me happy. Do you know what I'm saying?
Yeah, I know what you're saying. So basically, we can use whatever the logic we want inside the cache, and then depending on the.
Absolutely, okay. Nandakumar. That's what I mean by handling an exception. When an exception is thrown, when error is thrown, what do you want to do? I mean, all you want to do is show the user that, well, an error has happened. If you absolutely helpless, then show it to the user the same information, then I'm fine with that. But that's the last thing you want to do it, right? Before that you think, can I do anything? Yes. Can I do anything? hey, I understand. When I write the code itself, I'm saying, when I write the code itself, when I make a call to the PayPal, okay, then it's my code says that, hey, dude, this is a potential code. My compiler is going to say that, hey, this is a potential code. This is going to throw you a runtime exception. So how do you want to deal with the runtime exception? Can you handle Can you handle remote exception? I'm sorry. So can you handle that remote exception? So what happens if PayPal is down? Do you know how to handle it? If you know how to handle it, meaning put your try catch block there, and inside your catch block you retry it, because that's your logic, right?
Yes, yes.
Okay, then if you think that I don't know how to handle it, okay, then you throw it to your caller. Maybe he knows how to handle it. If he doesn't know that, then he will rethrow it to his client. Then if he doesn't know, then he will rethrow it to his client. So the exception gets trickled up if no one is handling it. If they're all rethrowing it, it gets trickled up, then it gets to the browser eventually. But do you want to show that kind of error message to the browser? So probably what happens, most of the cases, what happens is whoever is close to the browser, whoever is flushing to the browser before he flushed it, and he will catch all the exceptions and say, any kind of exceptions that come to me, I will take him to this generic error page saying an unknown error has occurred. Please contact this 1-800 number. I'm sorry. I apologize. All that stuff,
Yep. So
But
in that case, go ahead.
But if you can handle that itself, you handle it. If you want to retry it, please go ahead and retry it. Or if you don't have enough money in your checking account to do the transfer, maybe you can pull it from your money market account. Maybe that's a logic. Ask your customer, ask your business requirement. What's your business requirement? Well, if you call me to transfer the money from checking account to savings account, what if I don't have enough money from checking account? So what would I do? Will I throw an error? Sure, I will throw the error. I will throw the error definitely, saying that I don't have enough money. But what will the client do there? When he get the error, what can he do is the question. So you are the designer of the original code. Now I am the consumer of your code. Now I am calling your transfer method. I'm asking you to transfer it. I got the exception saying that I don't have enough money. Now what do I want to do it? Maybe I want to transfer some money into checking account from somewhere else and then make a second call to your transfer. Or if I don't have any other option, I'll throw it back to my client saying, I'm sorry, boss, the transfer has failed. There is not enough money. And if no one can do anything, then it gets trickled up all the way to the browser saying that, sorry, dude, you don't have enough money to transfer to make this happen. So I'm saying that's totally fine. But that's not the only handling scenario. So try to handle it as gracefully as possible. If you don't know, if you can't, then yes, rethrow it. Yeah, go ahead.
Okay, and so basically what it means is, my take on that is basically it's always good to put a top level try catch except for the main class, right? Say for example here the exception demo is their class, right? So basically I can put it on the main method so that I cover the complete try catch. Or should I go for method specific?
I'm not following that there.
No, here. So the try catch is basically for catching exceptions, correct?
Absolutely.
Okay. So basically we need to do that one for top level. So that means we have to do for the whole class. That's the better way of designing it.
You need to handle it for the whole class, meaning every single line of code?
Yeah. Is that the way to do it? Because you never know, whenever there is a logic, it's always good to catch the exception because you don't know how it's going to break during runtime.
Very good point, Nandakumar.
Is it a legitimate question? I'm not sure.
Very good point. So let me tell you. Sure. In a practical scenario, right? This retrying is definitely possible. Okay. And in those scenarios, probably you can retry it. But 80 to 90% of the times you don't know how to handle it. You don't want to handle it.
Yes.
So in those scenarios, what you do is you don't want to put just try catch just to print out the messages, because that becomes your code is getting cluttered with all the exception code. So you're making your compiler happy, you're making your runtime environment happy. So your responsibility as a Java developer is to take care of your business. But unfortunately, when you look at some piece of code, you will have 30% of it just for exception handling. If you just keep catching every single method and say try catch, try catch, try catch, try catch, try catch, and all you're doing is printing the e.print stack trace, e.print stack trace, e.print stack trace. If you're just printing the stack trace, then don't do it. You know what I'm saying?
No, basically I'm trying not to show any error message to the user.
Okay, that point I agree with that, but I want to explain briefly here. I'll get to you, Fami. We'll talk about it. So from browser, when you make a call, you go to the server, and inside the server, you will have multiple layers here. You have something called web layer, and from web layer to business layer or service layer, it goes to data layer, and then data layer to database. Okay, and then database will give you back the results to data layer will give the results back to business layer apply business logic, and then give it to web layer, and web layer pushes the HTML to browser. This is what happens in an enterprise scenario, right? My point is this one. If data layer here, this guy is dealing with the database. If the database is down, this guy is dealing with the database and database is down. So what can you do? I'm saying if the database is down, what can you do? Do you want to retry it? It's most likely possible that even if you try it 10 times, it will not, it's not up, is my point. Okay.
Chances are less. Chances are very less.
Chances are very less. If you want to take chance, yeah, go ahead and do it. Okay, try it 10 times. And then if you still can't do it, then trickle it up. Okay, and throw the exception. So you are not handling it here, because I don't want to deal with the scenario where database is down. If database is down, my whole system is down. It's very simple. Amazon like systems are also completely down if the database is down. Of course, they have backup and distribution, all that stuff. That's a different story. I'm saying if their entire database is down, everything is down, right? So I don't want to deal with that situation. So I will throw that error to my business layer. I say that, sorry, dude, something happened. I'm throwing the error. So I'm not handling it. And business layer is saying that I don't know how to handle it. I'm just rethrowing back. And then I'm saying the web layer is throwing back that exception to the browser. But web layer throwing the same exception back to the browser is a bad idea. So this is where you want to catch all kind of exceptions. You want to say that catch and the top level throwable, meaning everything under throwable. Throwable is the top level class, right? So all the exceptions, runtime exception, checked exception, everything you catch it, and then you provide a generic error page saying that, sorry, an unknown error has occurred. Now the point is, if you want to design for this situation, right? If the database is down, what do you want to do? Whatever the exception that you want to throw if the database is down, design that as a runtime exception is my point. Don't make your code, don't make your client to unnecessarily handle that exception. If you design that as a checked exception, then you're forcing your clients to do one of two things. Either they have to put the try catch or throws. Then if you design that as a runtime exception, then your compiler doesn't force you to do it, and then your clients don't have to do anything, and your client code is pretty clean. You know what I'm saying?
Yeah, I got it. Yeah.
If you don't know how to handle it, design it as a runtime exception, and don't make your client code clutter with all the try catch block just to print it, is my point.
Yeah, that makes sense actually. Yeah.
So, but if you're dealing with something like a network exception or dealing with something like a insufficient balance exception, absolutely, you design them as checked exception, insufficient balance exception. So when you design an exception, ask yourself two questions. Can my client do something about it? If this exception is thrown, can he handle it? Yes, insufficient balance exception. If this is thrown, then probably yes, my client can handle this scenario gracefully. Then design that as a checked exception. Database down exception. Can my client do anything if the database is down? Chances are extremely rare. Then design this as a runtime exception so that your client code is not cluttered. You are not forcing your client to do one of two things. Does that sort of make sense?
Yeah, definitely it makes sense. Yes.
Yeah, awesome. I mean,
thanks for clarifying.
No problem. No, I mean, that helps actually everyone too. Thank you for asking great questions. Okay, Fami.
Yeah, hi, how you doing? Well, I was just telling them to put that try and catch statement when it's unchecked exception, right?
Can you rephrase it? I mean, I couldn't get that.
What you're saying is basically to put use the try and catch statement on all unchecked exceptions.
No, on all checked exceptions. Because in the case of checked exceptions, you will be forced to catch it or rethrow it. But in the case of runtime exceptions, you don't need to catch it, right? Your compiler doesn't ask you to catch it. Okay. Am I missing something here?
Okay. Well, that's right, because if you already know that it's going to break down on runtime, then why don't you do something about it early? Okay. Okay.
Runtime exceptions are programmatic errors for me, right? So what do you want to do with it? You don't want to do anything, but my point is always do something here close to the very last client, the web layer, right? So here you catch everything, all runtime exception, checked exception, everything exceptions. The reason you want to do it here is because you don't want to penalize your real customer, the human being, with all the garbage, right? He doesn't want to see the null pointer exceptions. So only catch here, but in the business layer, in the data layer, don't catch it. Just throw it back. Why do you want to deal with it? I mean, what do you want to do if there is a null pointer exception? And what do you want to do with it if there is an error index out of bounds exception? Tell me. You don't want to do anything, right?
That's right.
That's the point. So what we are going to do for unchecked exception. Okay, let's open Alum. Can you ask again, Alum, please? I mean, based on what I just said, so can you?
Okay, maybe I lost something. For check exception, we use try, catch, or maybe throw under that exception. For unchecked exception or runtime exception, what we are going to do? We are doing the same thing, or is there any other things we should do?
Okay. In the case of unchecked or runtime exception, compiler does not force you to handle it. You don't need to handle it because runtime exceptions are generally thrown because of programmatic issues, and generally you cannot handle them. Generally you can't do anything about them even if you want to handle it. So that is why compiler does not force you to handle them. If they are checked exceptions, then compiler will force you to do it. Does that make sense? Hello, Adam? Hello? Okay, okay. Sounds good. Sounds good. Thanks. So it's a little tricky. Please, try to understand. I will explain any number of times, so please don't hesitate. Okay? Just want to take a look at my exceptions. Now, who catches it and who throws it? Okay. Sure, Tom. Go ahead.
Yeah. Well, go back to the screen you were just on, the class you were just in. If you have a throws, that can only be for a checked exception. You can't throw a runtime exception. Is that true?
Very good. Well, you can definitely throw a null pointer exception too here, okay? And you can say have an exception too, okay? You can definitely you can put the throws for a null point, throws for a runtime exception too. Any runtime exception you can put in your method signature. But what does it buy you?
Nothing.
It doesn't buy you anything. For the simple reason being that null pointer exception is a runtime exception. See, my client, he knows that my main method knows that print to a file throws null pointer exception, but compiler is not asking me to do anything. He just ignored it. He just ignored the fact that you throw a null pointer exception. I don't care because I don't know, because it's a runtime exception and compiler doesn't force me to handle it. You know what I'm saying?
Yes.
You can absolutely put throws, but it doesn't buy you anything. It doesn't.
Well, but the runtime exceptions are thrown by default, right? It's going to get thrown regardless. If there's a runtime no pointer exception, it's going to get thrown all the way back up the chain.
Oh, absolutely.
Automatically, without doing anything. Right.
Yep.
Okay.
See, throws highway exception, right? So let's do this one. This is okay. This is okay. Then let's say print writer out equal to null. Okay. So what would happen here? Print writer out equal to null. Then you are saying null dot write. So what exception you have to expect? You have to expect null pointer exception. Well, this guy threw null pointer exception. And similarly, in this case, if I put a different drive that doesn't exist, it threw an IO exception. But in this case, it is only helping you during coding, Tom. Whether it's a checked exception or runtime exception, it is going to help you handle in your code. Your compiler is helping you by forcing you to do one of two things because you are calling a risky method. But in the case of runtime exception, or checked exception for that matter, if it's thrown, it's thrown. That's all. You know what I'm saying?
Yes, I understand.
So that's all. Yeah.
Okay, so then back to the notepad or the drawing where you show the business layer and the web layer. So that catch, the catch throwable up in your web layer, that would wrap around the whole class.
Oh, that would wrap.
It would be a try.
Generally, okay, we don't wrap for the whole class. Okay, what happens is in the web layer also there will be a method, right? So you are asking for something. Give me all
Okay, whatever method's going to the business layer.
Give me all books. Give me all books. Okay. So here what I do is try, catch, throwable. Because this is the only location where I want to say, in fact, if you do this one, this is a bad practice, you know. Other than here, you don't want to do this one anywhere else. You want to do this one only here, because if you do this one, if you catch the whole throwable, or if you catch the whole exception here, then you are eating all the exceptions, right? You never want to do that. So that's why you do this one only in the web layer, and the whole method here you call the business layer. You know what I'm saying?
Right. Okay.
Yes, Fami,
Okay.
you have a question?
Yes. So let's say the method you're trying to call has thrown a null exception, okay? And the client, the calling code, is trying to handle that exception. Can you just put like just a regular exception instead of like go back to that screen that you were in before this one? I'm sorry. Okay. So let's say you're calling this from a main method, okay? You're calling into a file from a main
Are you
method.
saying this one, directly exception?
Yes.
Absolutely, you can do it.
The print to file, okay, has a thrown exception of IO exception, right? So let's say if I want to handle that exception in method, right?
Yep. Let's do that. Okay. I don't want to rethrow it, okay? Because I know how to handle it. So let's do that. All you have to do is, what do you want to do? Try. Put this guy in catch. Sorry, put this guy in try and say catch.
Okay,
so what happened here? So who is the client here and who is the service? Tell me. So tell me, who is the client and who is the service? This is the service, right? And this is the client, right? So what happened here? This guy is calling print to a file which can potentially throw an IO exception. And what this guy is saying that, okay, I understand my client is throwing an IO exception, but I know how to handle it. Give me control, give me the handle, I know how to handle it. So he's handling this guy gracefully. But of course he's not doing anything, print stack trace, but put your handling logic here. That is my point. But don't print the stack trace always, okay? In fact, this is a bad idea. This is a bad idea. Printing the just stack. Printing the stack trace is not a bad idea. But when you do this ex.print stack trace, I can't explain right now. It doesn't actually print it to your application log. It actually prints to server log. That's why you always want to use your logging mechanism, log4j or something like that. So we'll get there. So tell me.
The print to a file, okay? What if you, like earlier, the throws IO exception, and let's say it would throw a null exception as well, a null pointer exception? So how are you going to handle it from the method if you want to handle that?
Oh, this one? Absolutely. Yeah, that's my next topic. That's my next topic. Okay, first understand that this can throw more than one exception, and also understand that this can throw a runtime exception also. But your compiler doesn't force you to handle this guy. See, compiler is forcing you to handle this guy because this is a checked exception, but compiler doesn't force you to handle this null pointer exception. But if you want to handle, absolutely you can handle it by putting one more catch block and say that, hey, null pointer exception, give me handle 2, please, okay? I'm handling null pointer exception too. Or maybe I don't want to print the stack trace. All I want to say is I got null pointer exception. That's called NPE. in short term. Null pointer exception is generally called LPE, NPE. So do you want to test that? Sure. Out equal to null. When you call a method and a null reference, that's when you get NPE. Right click, run as Java application. File not found exception. Oh, here itself I got exception. In this line itself, I got an exception. So see that? I got an NPE. Makes sense, right?
All right.
Does that make sense? Does it make very clear here?
Yes, indeed. Thank you.
Wonderful. You're welcome. Awesome, awesome. So what's the next thing that I wanted to say? Who catches it and who throws it? Method needs to declare that it might throw exception. Yeah. So if your method is going to potentially throw a checked exception, you have to put this in a method signature saying that throws IO exception. So what are you saying here is just by reading the method signature, when someone reads this guy with all the other piece of information, like method name, my method name is print to a file, and I'm taking 0 arguments, and my method return type is void, and I throw IO exception, meaning I potentially throw IO exception. So be ready to do something. Okay, be ready to handle that guy is my main point there. That's what I'm doing in a method signature. And of course, you will not have an option. If it's a checked exception, your compiler will force you to do one of the two things. So yep, either handle or declare. That's all at this point. I wanted to talk about something else though. Something else called finally block. So typically you will have a try block where you put the potential code that can throw an exception, and then in the exception block is where you handle an exception, and then there is a third block called finally block. So there is a third block called finally block. Understand this very carefully. Here in try block, I have line number 1, 2, 3, 4, 5. Okay. So what happened here is in line number 2, there is an exception. And of course, that was caught here. So this guy came into picture and he caught it. What happened? What did I tell you earlier? If you have 1, 2, 3, 4, 5 line numbers, if line number 2 throws an exception, it directly jumps to the catch block without going through 3 and 4 flag. Okay, that's what the general scenario is. So, and then in the catch block, whatever you want to do it, you catch it, or in the catch block also you can rethrow it. We'll talk about it in a second. But the point is, if you have an absolute piece of code, that absolutely need to get executed, then you need to put that in your finally block. Okay, I'll explain with this an example. Exception demo 2. Yeah, see this one here? You have a file writer. Let me not catch this guy. Sorry, throws that guy. I'll say catch everything. It's a beautiful concept here. Okay. Do you know what happens here? When you open this file writer or print writer, when you get handled to this file writer or print writer, what happens is you're actually opening a low-level socket with your hard disk. Okay, so you're opening a low-level socket. Once you are done reading a file, then you want to close that low-level socket so that that can be used for something else. You never want to leave that connection open. Similarly, one second, please. Similarly, you're dealing with a database. So connecting to a database is an expensive thing. So when you make a connection to the database, you are actually opening a low-level TCP/IP connection. Well, you make a connection to the database and you execute whatever the query that you want to execute. And once you are done with your work, you close that connection. Because database can only handle certain number of connections, and you want to return that connection back to database so that that can be open for someone else. So this kind of for this kind of scenarios where you are dealing with expensive resources, okay, very sensitive resources, you absolutely want to make sure that they are closed after your work is done. So your file writer is supposed to be closed once your file writer is done. Your print writer is supposed to be closed once that is done. Otherwise, what happens? Your low-level TCP/IP connection will be open, and then you will have memory issues. Because it cannot write, it cannot scale well, right? Because you have the connection open, and it can open only so many connections. So in that scenario, now let's mix these two situations here. I have a file writer here, I have a print writer here. Now, while writing out.write, there is some problem. Or this line, when I did something here, print writer out equal new print writer, when something happened here, I got a null pointer exception. What happens here? I'll get a null pointer exception. So this line does not get executed, this line does not get executed, this line does not get executed. So what does it mean? That means that your connection is open to your file system, but the connection is not closed. You did not close it because it never get to this place. Because an exception is thrown, and if an exception is thrown, the rest of the try block will not get executed. But no matter what happens in the exception case, I don't care whether an exception or non-exception or anything, I want these two crucial lines of code to get executed. Absolutely, in any case. So what do I do in that scenario? Well, in that scenario, what you have to do is you have to use another block called finally block. Okay, so if you put some lines of code inside this finally block, then JVM makes sure whatever happens here, it will make sure that lines of code inside this finally block will get executed. then this is where I want to put my out.close and file writer.close, because I want to close the connections that I opened earlier with my file system, because those are very expensive. I don't want to leave them open. So this out. So what you do is file writer out, file writer equal to now, and then because you don't have, now you say file writer equal to new file writer and print writer, sorry, out equal to new print writer of okay. So again, see file writer dot close. When you close this file writer, it's saying that file writer dot close, again throwing an IO exception, meaning if the file writer itself is not open, then maybe if you try to close that, it will throw an exception. Or maybe file writer is null, then what happens? So what do you want to do in that case? Well, what do you want to do in that case? You don't want to do anything, right? So either you catch it, or I'll say I'll rethrow it, add throws class. So I don't want to deal with the situation if there is an exception, or the best case actually for this one is if close doesn't happen, if there is an exception while closing it, then I'll leave it, because that's a trivial thing, right? So what I want to do in that case though is I'll catch this one, surround with try catch, and say I'm just printing the stack trace. But the point you want to keep in mind though is this line of code, file writer.close and out.close. These two lines of code should be inside finally block, not inside the try block, because you want to make sure those two lines of code get executed no matter what happens, whether an exception is thrown or whether an exception is not thrown. All the DB connections open, you have to close them in finally block. All the file resources stuff, you open them in your try block, but you close them in finally block. All the crucial stuff. So that kind of resources, you always want to close them in finally block. Otherwise, maybe they never get to this. You can close this one here, absolutely, but maybe it never gets to that. What happens if there is an exception here? Then it never gets here. That's why you use finally block. So finally block is a block of code. JVM makes sure it gets executed no matter what happens in the try block, whether an exception is thrown or not thrown. Nandakumar, yes, go ahead. You have a question?
Yeah, I have a question.
Yes.
So you said, like, when, for example, let's take this database connection one. Mm-hmm. When it fails, like, then that's where it goes to finally where we can close it, right? Mm-hmm. Okay. So when there is a database connection, mm-hmm. when there is an exception thrown, mm-hmm. it will go immediately to catch, right?
Yes, absolutely.
So my question is, why can't we close the database connection in the catch? Is there any reason why we have to do it only in finally, or is there any potential issue mm-hmm. doing it in catch?
Okay. Catch block, absolutely there is a reason. Catch block, okay, it comes to catch block if there is an exception. What happens in the happy scenario? It doesn't come to catch block. So what happens in that case? Your connection will not be closed.
Oh, I see. Instead of doing it 2 times, we are doing it 1 time and finally, okay.
You want to close the connection in a happy scenario. You want to close the connection in an unhappy scenario. In both the scenarios, you want to do it. You know what I'm saying?
Yes, we have to do in both scenarios, yes.
Absolutely. So finally block gets executed no matter what happens. Even when you put it in a written statement there in the try block, even when you say written, whatever you're returning, even in that scenario also, JVM says that, hey, I have a finally block. I have to execute this guy because it's a very crucial piece of code. Make sense?
Yeah, definitely.
So that's about the finally block. Okay, I mean you always want to execute that in finally block. So now my method is not throwing any IO exception here. Okay, so now it is saying, hey, unreachable catch block of block for IO exception. This exception is never thrown from the try statement body, meaning no one is throwing IO exception. Why are you catching it? It doesn't let you catch if it is a checked exception. So that's what happens here if no one is catching. Oops. Yeah. Okay, Fami, you have a question? Instead of putting close method in try and catch block, why not put if it not null? Well, let me give you the situation here. Okay, even if it is not null, okay, even if you put it in this, where is that? This file writer is not null, okay, or out.not null. Even in that scenario, this line of code is throwing an exception that is checked exception. Do you have an option?
That's
If
right.
a line of code throws a checked exception, do you have an option? You have to do one of two things. Either you catch it or rethrow it.
I see. Okay.
Okay. So here, take a look at the good design scenario here. Okay. So here, I can say that, okay, by the way, how am I coming here? Control 1. Control 1 is a quick fix. Control 1, add throws block. I can put a throws block here. You know why I didn't do it? You know why I said that's not a great idea to do it? The reason is, if I'm not able to close the connection to my file system, I'm throwing an exception. Ask yourself, do I want to penalize my client if I'm not able to close the connection, which is very trivial? What can he do in that case? Actually, tell me. And why do you want to penalize the end client anyway? Right?
That's right.
It's so
That's right.
trivial. I mean, if it's open, then you wanted to close it. But if it's not able to close it, then you are fine, right? You know what I'm saying?
Mm-hmm.
Yeah. So that's the point. That's why I designed this way. Try catch. In fact, I just leave it. I don't want to print the stack trace also in this case. If you got an error while closing it, I don't care. That's fine. Okay. I don't even put stack trace. I don't even put it. This is one of the scenarios I'll put like empty block, or I'll put a single statement here saying that error happened while closing it. In fact, I don't need to put it also. But generally, if you leave this catch block empty, it's a bad idea. When you, in the real-time environment, once your code is done, you give it to your technical lead or whoever that one is, architect contact or someone for technical review, okay, or your peer. It doesn't have to be tech lead or architect. You can give it to your peers. They look at the code review. They look for review, and then they point this one. You should never swallow an exception, meaning you should never say catch block and do nothing about it, because you are not doing anything. If you don't want to do anything, at least put some information in logs, because otherwise customer says that everyone will be looking in the logs, hey, I don't see anything, but for some reason customer is not getting what he wants because you swallowed the exception. That's called swallowing the exception. You never want to do that. You never want to put an empty catch block. It's a bad practice. Go ahead.
In this case, you could test it in that try block, right? To see if it's null or if it's not null. That way you don't have to do anything under, you don't have to do anything under exception.
What are you saying? Oh, here you are checking whether file writer is null or something?
That's right.
Okay.
Would that be like a better
I have a
place to
question.
check it?
I have a question now. Okay, I have a question. You absolutely have to check for null, and you absolutely have to put this whole thing also. You know why? If file writer is null, you will not get IO exception for me. You will get a null pointer exception, and that will be trickled to your guy, your client, and you are penalizing your client because your file writer is null. So you should check for file writer whether it's null or not. You know what I'm saying?
I see. Okay.
Do you know what I'm saying?
Got it.
So if file writer is not null, then do this guy. Otherwise, what happens? He will get a null pointer exception, and null pointer exception is a runtime exception, and you don't do anything about it, obviously, so it gets trickled up. And your client doesn't do anything, it gets trickled up. He doesn't do anything, it gets trickled up, it goes all the way to the browser. So avoid the null pointer exceptions. Because it's a code issues, right? What happens if the out is null? What happens if this line of code gets an error? Then your out remains null, and it comes to finally block, and your out.close will throw a null pointer exception. So there is an exception here and came to finally block, and this is throwing an exception. So throwing an exception from finally block is a bad idea. So you try to be careful. Out is not null. Because the repercussions are serious if you throw an error in a finally block, because if you didn't do this check while closing this one, if he gets null pointer exception, the rest of the piece of the code will not get executed. So that's problem, right?
Right.
So always avoid null pointer exceptions or any kind of code issues, array index out of bounds exception. When do you get array index out of bounds exception? If you don't check the length of your array and then try to just blindly go get the object, right? So I'm just telling you. Okay, can you just give me 1 minute? I just need 1 minute break. Okay. I'll just come back in a second. Okay. I'm back. I want to tell you one more thing. What I want to tell you is, I'll tell you once I talk about the custom exceptions. Yeah, I'll tell you when we talk about the custom exceptions. So there are so many exceptions that JDK is giving you. All these, runtime exceptions. There are so many runtime exceptions, null pointer exception, array index out of bounds exception, arithmetic exceptions, and all that kind of stuff. And there are so many checked exceptions, file not found exception, IO exception, and so many. So, but you can use these exceptions wherever possible. If you're expecting a calculator, and then you say in the calculator example, if they give you bad operator, by default you support plus, minus, star, and division, okay? Then if they give something else, some jank, then you can throw illegal argument exception. They provided the wrong argument. So you can provide that. So you can use the exceptions that are given by Java wherever you want to. But you can create your own exceptions too. As I told you earlier, there is a transfer that you want to do from checking account to savings account, and there is not enough money in checking account. So in that case, you want to throw your own exception called insufficient balance exception. There's no such thing called insufficient balance exception. Then you create an exception. So how do you create an exception? It's very simple. It's like any other class. Right click, new class. I'm creating insufficient balance exception. But the only requirement is your exception should extends either exception, java.lang exception, or runtime exception if you want to design that as a unchecked runtime exception. If your class extends exception directly, then this is a checked exception. So my insufficient balance exception is a checked exception. How about my database down exception? Database down exception. That's going to be my runtime exception. So you have to extend runtime exception. So if your exception extends runtime exception, then it's unchecked the runtime exception. Otherwise, if your exception extends regular exception, that's checked exception. So this is how you define your checked exception. So do you want to provide a constructor with the error message? Do you want to? Sure. So you say public, you provide a constructor, string error message. So someone calls this one as insufficient balance exception. In the double quotes, you say, sorry, there is not enough money in checking account. You want to say that. That's an error message. So there are enough constructors in your superclass exception, so you don't have to do anything. All you do is just call your superclasses constructor. How do you call your superclasses constructor? Using a keyword called super. Okay. So how do you call your superclasses method? Using super dot, right? So I'm calling my superclasses constructor that takes string error message. All I'm doing is this one. I'm not doing anything. Of course, I can go fancy too, but I'm not here. I created a constructor that takes error message, and I just call the superclasses constructor, and it will put this error message inside the stack trace. Stack trace is a complete message that you will see when you say exception.print stack trace. And since your exception extends exception, it will when someone says extend ex.print stack trace, then they will get your error message also. Or when they say ex.get message, then they will get error message. We'll see that. Same case with the database down exception. You do the same thing. Database down exception. But my constructor is error message. I'm passing the same error message. Very cool, right? Now let's write a piece of code that throws insufficient balance exception. So I'll say bank transfer. I'll say bank transfer service or transfer service. Sure, I'll say transfer service. So I have a class called transfer service. This transfer service has a method called transfer. So public, it doesn't do anything. It doesn't return anything. It just transfer. Double. How much? How much do you want to transfer? So here I'll say if. Ideally I should check. Okay. So I have this double checking account balance, or probably I'll say here instance variable checking account balance equal to, I'm starting with 10,000. Okay, and savings account balance is also 10,000 to start with. So if how much is greater than checking account balance, then I want to throw an error saying, dude, you don't have enough money, right? Then this is how I throw it. If you want to throw an exception, so far you never throw. You never threw an exception. So all this while someone else is throwing an exception and you're catching it. Earlier when you file writer or print writer, that was throwing it and you were just catching it. Now in this case you got an opportunity to do reverse. Now you are throwing it yourself. Okay, let's do it. Use this keyword called throw. Throw new, and then you create an instance of whatever that exception is. What is that? Insufficient balance exception. And then you say, sorry, not enough money in checking account. Okay, see that you are throwing it. But when you're throwing it, what are you throwing? You are throwing a checked exception, right? Then your compiler is forcing you, dude, your piece of code is throwing a checked exception. Then what do you have to do? You have to do one of two things, either catch it or rethrow it. There is no point in catching because you are throwing from your code itself. So you declare this in your method. Since you are throwing it, okay, see this? Unhandled exception type insufficient balance exception. So throw this in your method saying that my method throws insufficient balance exception. So you are telling your clients that, hey clients, whoever calls this transfer method, be prepared to catch this insufficient balance exception. I can potentially throw that exception is what your message. Okay, if there is no exception, so if it's greater than, it goes there. Otherwise, you'll say that checking account balance minus equal to by how much? Okay, meaning checking account balance equal to checking account balance minus how much? That's what I'm doing here, minus, because you are removing from checking account. You are taking out from checking account, right? So now you're depositing to savings account. How much? Okay, now you can provide some getter methods and getter methods. You say source generate getters and say getters, because I want to get the information about, okay, what is after the transfer, what is my checking account balance and what is my transfer account balance? Sorry, what is my savings account balance? Super. So now, who is my client? Transfer service. Who wants to do the transfer generally in banks? Can anyone throw? Who will be the client for transfer service? Can anyone tell me? Shall I call it transfer service client?
The customer.
Or customer wants to do it?
Client, you can call client. Yeah.
Sure. Okay. I'll say customer. Bank customer. Okay. So now bank customer obviously has public static void main, and now this guy says that a transfer service equal to new transfer service, and say that service dot transfer. I'm transferring $5,000. Okay. Now see that? Hey, I'm trying to transfer $5,000. then my compiler is saying something here. Unhandled exception type insufficient balance exception. Hey, this is risky code. So you are calling a potential risky code. So this method could potentially throw insufficient balance exception. Do something about it. You can do two things here. Can you handle it? Yes, go ahead and handle it. You can't handle it? Rethrow it to your client. You know what I'm saying? Well, I want to handle it just for the sake, because I want to see the error message. It's not because I can handle it, but mainly because I want to see the stack trace. That's all. So, and then once the transfer is done, I want to see the service dot get checking account balance. I want to print them. Savings account balance. Okay. Wonderful. Let's run it. Run as Java application. Cool. No exception. So checking account has $5,000 and savings account has $15,000. Very cool. No exception. Pretty cool. Now you say you transfer $8,000. What happens now? It will have $2,000 and $18,000. Very cool. Our transfer service is working great. Well, let's try $18,000. What happens now? Run as Java application. Ooh, see that? COM training Java core exceptions, insufficient balance exceptions. Sorry, not enough money in checking account. Whatever the message that you put it here, it's getting, because you call the superclasses exceptions constructor, and that will put it properly and made it available to your stack trace. So my customer got that. And of course I printed my balance is pristine, 10,000 and 10,000. I'm very happy because I'm not seeing any inconsistency in my balance. Very cool. Did you get that? This is what happens. So if you change that to a runtime exception, then you don't need to do this one, try catch. That's what happens with the database stuff. Does that make sense? Now, did you get the complete picture of what an exception handling is and you know how to handle it?
Yes.
Yeah.
Everyone?
Yes.
Yes.
Yeah?
Yes.
All S's?
Yes.
Does that make sense?
Yes.
Wonderful. Wonderful. I mean, it's not easy. It's not rocket science. So, sorry, it's not difficult. So, I mean, it's pretty.
I mean, you wouldn't do this in the real world, this particular scenario.
Oh, this one?
Yeah.
Why not?
Well, wouldn't you just, I don't know, it seems to me you would check the balance before you try to do the transfer.
Oh, okay. You're talking about this particular thing here? Yeah. I mean, you want to do that. Absolutely. So you are being defensive there. That's a defensive programming, right?
Right.
You are being defensive there. But here you are being superstar. You don't care. You handle it. See, exceptions are also messages to clients. But as Tom said, try to be defensive as much as possible. You know, rather than throwing an exception, rather than communicating with the exceptions. If you can avoid it, try to avoid it. In fact, you just make a simple call saying, hey, does he have enough money before doing that? Well, if he doesn't, then, well, but how do you want to do that, right? I mean, in this case, the same thing actually, transfer service, but this is defensive already. Do you have enough money? You are checking actually. If you don't have, then you are throwing insufficient balance exception. But if you can, wherever you can, try to avoid it. but exceptions are a great way to send messages to your clients too. So this is how you are sending a message to your client saying you don't have enough money in your bank account. So this code is absolutely fine. So any questions, any comments, anything regarding exception handling? It's a neat concept. We are going to use it so many times. So we'll create our own exception called DAO exception later on when you talk about JDBC and data X object pattern. So I would say try to create as many exceptions as possible and try to throw as many exceptions as possible like this, like in the case of transfer service, and then you handle it and you play with finally block. Oh, there is an important interview question there. What is the difference between final, finally, and finalize? I know I haven't talked about finalize, but finalize is a method that is called right before the garbage collection collects your object. That is finalize. We generally don't use this one, but this is to instruct garbage collection that, I'm ready for garbage collection, and this method is called right before the garbage collection. But the final has three different meanings in three different contexts, right? Final variable is constant. It cannot be changed once it is assigned. Final methods cannot be overridden, and final classes cannot be subclassed. And finally, there is a finally block. And finally block is a block of code that absolutely gets executed no matter what happens in the try block. Even if an exception is thrown or not thrown, finally block gets executed. So keep all of your sensitive code, where you want to close the resources to database connection or file system, then do all of them in finally block. Very important. We only have 5 more minutes. 7 more minutes. So I don't want to talk. I don't want to start another topic today. I want to talk about JDK 1.5 new language features. So in the next class. So we'll see you on Saturday. Okay. Have a good night.
Okay, good. Thank you.
Good night.
Yep. Good night.